Yo, what's up, everybody? Welcome back. Today we're working on our barcode scanner. So for context, we're making a meal tracking website, because I don't want to give all of my food data to some like corporation who's going to sell that for money, right? But I also want to like have information about, what I'm eating over time, as well as like utility to let us, like automatically list like, hey, what things do you make that you have the stuff in the fridge to make, right? And so part of that process is tracking all of the stuff that I have in my fridge. And so I'm thinking, I take out my phone, and as I'm loading the fridge, I go beep, 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 right? And then we have the stuff in the fridge. We know what's in the fridge, right? So we've been slowly writing a barcode scanner. We started by trying to we wrote like half a barcode scanner with no real like image pre-processing. We're just like, if black pixel black, if white pixel white, and that kind of didn't work too well. So yesterday we did some experimentation with the canny edge detector, right? So we have like some pretty solid lines here that are bisecting the white and dark sections. Some things have like changed a little bit since yesterday. So we were in happy hour experimenting with kind of like taking the ideas from the canny edge detector and kind of like tuning them for our use case, right? So we know that our edges are only going to be horizontal, which means that we don't have to do a lot of the like gradient searching that they did. Our suppression of like large gradients can be kind of like done on the fly, because we know again that we don't have like directions to worry about since everything's horizontal. We can kind of just like average out gradients as we go. And we've got something that like works pretty well. So this is a 768 pixel wide image, and we have some pretty solid lines. And so I think what I want to do is now turn these lines into like a barcode scanner. So the barcode scanner that we were writing the other day, we were looking at like pixels. And part of the thing that we have to do there is we have to like count how many pixels of black do we have, then how many pixels of white do we have, then how many pixels of black do we have. I think that we could probably gather that data as we are generating these edges, right? So all we have to do is like, since this is like a completely like one pass procedure, we're kind of like walking white pixel, white pixel, white pixel, white pixel, white pixel, blah blah blah. Eventually we go like, oh, here's a transition. And so what we should do is just like on transition, I think we can just write down, hey, we had like 100 white pixels here, and then like keep walking, blah blah blah. Oh, 3 gray pixels, and then keep walking. Oh, 5 white pixels, blah blah blah. Oh, 3 gray pixels, right? I think that operating on that data will actually make this whole barcode scanner thing a lot simpler, which means that like the existing barcode scanner has to be like, that's not finished, has to be rewritten a little bit, and we also have to like construct that data. So I think the plan is to start by run length encoding these things, basically take the average value of everything between each set of edges. Maybe we find some way to visualize that to make sure that we got it right, and then start like reworking our barcode detection so that it works on that data, and then we'll see how far we get. It should be pretty doable, I think. But let's see. So, RLE, run length encoded edge detections. So, right now, we have like just raw dogged in main, some process to generate these edges. And, at some point, we check here. We say, hey, if we found, we found like a hump in gradients, i.e. like a part that had the fastest area of change in pixel value around us, write that down here. And I guess here, what we should do instead is like, take our like row RLE, row run length encoded, mark edge or something, right? And then maybe on every pixel here, we just source the value from this thing. So we say it's like, hey, row run length encoding, push pixel. And this is going to be from the source image, I think. Image inner data at the current Y position times the width plus X. Yeah. Cool. So what is in our like row RLE? RLE generator. So it should just be like total. And this is of some type, probably usize is fine, and num entries, right? Then this is like going into somewhere, right? So we have like, I guess like an allocator here, or maybe like a stood array list or something of U8s, right? Because pixel values are from 0 to 255. Yeah. Let's do this. That seems reasonable. So what did we say? It was like push pixel? Okay. So this guy is what? Self row append. And this is not just a U8. This is a RLE item, right? So this is the val and the length, right? How many pixels is this thing valid for? Boom. Okay. So when we push a pixel, we add to the total. And num entries is increased. Okay. And then when we, what do we call the other thing? Mark edge. So here we go, okay, we found an edge. Let's fucking put that data that we have right now into our row. So we say self row append this thing that's like val is total over num entries, right? We take the average value, and then the length is num entries. Then we clear those. Okay, sure. Seems reasonable so far. We need an init function for this thing, probably. Okay, and we return row is equal to array list u8 initialize the allocator. Boom, easy. This thing can fail because it does an allocation. Okay. So this is initialized with our arena, and for everybody who's like, Jesus Christ, what awful code quality. I know, okay? All of this will get cleaned up later, but in prototype mode, we're like totally willing to just like be shit. Okay, so now I would love to like maybe just print that thing for each row. I guess this row needs to be reset every row, if you think about it. Row RLE, can we just like stood debug print what we got? We probably need to mark the last edge too, right? Okay. Did I do something fucking dumpty? Yeah, I did. I did type duplication and wrong. Huge. Okay. Maybe we should new line here. Still, that's a lot of content. But like here is like a row, right? So we get like a 67. This is impossible to parse. This is impossible to parse. Also, a division by 0 is really bad. So here we should be like, if num entries is equal to 0, return. That kind of fixes this. Okay, here we go. So in some of these guys, we're seeing like really short runs. So at the very few bottom pixels of this guy, we're seeing like what seems to be like, oh, here, it's making it all the way over here, right? So we're seeing 752 pixels of average value 136, then value 91 for 6, right? So that'd be like this. Then value 83 for 7, that would be this, right? Then value 148 for 3, that'd be this. Okay, so that seems to be doing, maybe what we want. Maybe. Very interesting here that like the difference between this and this is like very small. That's like maybe interesting, right? We might want to do like if we assume that these edges are soft, right? We might want to weight the average towards like things in the center. You know what I mean? There's like maybe something there where like maybe taking a raw average isn't good enough. But let's try to render out these things and see like what this looks like after we do this process, right? So let's rip through these guys. So we're gonna maybe say you know RLE on R on RLE. RLE back and forth is going to be an image of U8s, right? That is kind of like the initial image size, I guess. Okay. And we're going to say here that like for row RLE row items item, we're going to say var x is 0, probably. For item length, we say x plus equals 1, and we write into the RLE back and forth image at y times image RLE back and forth width plus x. We write the value. Yes. Okay, and then we do that over and over and over again. Okay. Seems reasonable. And then can we try write a U8 ppm of RLE back and forth with RLE ppm maybe? Let's kind of see how that looks. I think we fucked something up. I think we did something wrong. X should equal like the width of the image here, right? If it doesn't, then we have like a fucking bug. Yeah, so that's not happening, which means that like our run length encoded data is like wrong. How did we manage to fuck that up? So as we walk the width of the image, we push a pixel. So every single pixel should get pushed. Can we do something like this? Num pushed pixels. Just as like a debug metric here, we can do this. Every time we push pixel, num push pixels plus equals 1, right? Can we check row RLE num push pixels should be the width of the image? So that is true. This has to go outside the loop, that's why. Oopies. Maybe not, actually. So here for each, oh no, yeah, for this row, What is it? X and... Is it close? Just off by 1? 753? 753? What is the width? It was just like off by 1? It's off by quite a bit. 753 to 768 is not great. So what is going on here? Maybe length here is off by 1. Nope. Or that could be... Okay, so let's see. On the first pixel we push, num entries becomes 1. And then we say that we have a thing of length 1. No, so that should be right. That's really confusing. It's confusing that we have... Okay, can we like length sum? Surely if we say length sum plus equals item length, surely this should fucking hit, right? Oh, this assert is just happening in the wrong fucking place. It should be happening outside. I'm a dumbass. I'm a dumbass. Yeah, okay. Now that's working. Okay, that's good news. That's a little concerning. A little concerning, right? The difference between these is really not that much. And then we also have some like problems where the threshold of the edges isn't good enough. So can we just like allow more edges through? That's here. Okay, so there's some concern to be had here in general. Yeah. So I think we need to do what we said, where we want to like in here. I mean, maybe it is just really gray. Like, why is it... So in this, like, what, 5 pixel area? It really is, like, relatively gray. So how do I know that this is white? I guess I'm using, like, some context that it should be white. That's part of what's happening. Yeah, it's only part of it. But I think also it's that it's nonlinear. We're gonna have to fix this as well eventually, but I'm gonna ignore that for now. Because I suspect that there is at least one row in here, or like some rows in here that are correct. And then maybe if we like resize later, things might come for free as well. But I mean, we do still have some signal here, right? We do have signal that this section is lighter than this section, right? So maybe that's okay. Maybe it's okay. Because maybe if we do our barcode scanner looks for transitions of dark to bright. Oh, but like there are some edges that are like false edges, right? There's like stuff like this that we have to account for. Where is it? That's like here somewhere. It's like dark, 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 light, dark, light. It's like here, right? There's like an edge here that we need to like know that the difference is small enough to ignore. Which is fine, yeah. We can dissolve edges where the length we could dissolve edges where where the value is too close together. Yeah, that should work. So we can say here, like, if last, if last entry, hold on. So last or null, if there is a last entry, and if last entry dot val, these are both unsigned, which makes this a pain in the ass. Do they have like difference in here? No. Diff A B. Whatever. Okay. Return, like, if A is larger than B, return A minus B, else return B minus A. Okay, there we go. Okay, so if the difference of this and I guess here we calculate the average. Okay, so if like we're similar, you know, by some threshold, then we say like last entry dot length plus equals num entries or something. Yeah, something like that. Something like that. Yeah, something like this. Fine. This, there's no like get last pointer or null. So it's like if self row length items self, yeah. We do this. Like this, self row items len -1. Okay. Okay, let's see what that does. So we're looking for if we can still see this edge, which we can. So this threshold, refresh. Okay, see there, we managed to like get rid of some of this edge in there, which is good. Bad news, it nukes this edge. So I think this is not the play. Okay. Take 6 horizontal sample rows at even intervals, and the average should be correct. Oh, you're saying use like vertical information? Yeah, that's not that crazy. Like you're saying like no, I think there's something else going on here. I mean, we could also do contrast enhancement off rip. Maybe that's the play. Is if we increase contrast before we even do edge detection, like maybe that makes this problem a lot less bad, right? So like here, right, like in code, let's ignore the fact that we don't know how to do this right now, right? But if we kind of like said like do this, You know, like take this area and just kind of like make that the center. Then like the edges would be amplified, I assume. Yeah, can we try that? So we just say like this and like this, right? Just like contrast enhance the fuck out of this. And I think just like matching the two humps is the play. I mean, but I mean, that doesn't solve the problem that in here, the difference is just small. But I guess let's see. So we do this. Export. Let's just see what that does to our picture. Wrong one, maybe? Yeah, it doesn't really solve the problem in here at all. Especially like here. That's fucked up. I mean, another option here is that we've just resized too small. Right? That's a definite option here. Is that like there's just not enough pixels in there for it to like see the brightest one. Or our like resize mechanism was wrong. Right? So can we try? What the fuck is this? Get the fuck out of here. Open the original again. And this is 2048 wide. I mean, this still has the same problem, right? Even in the original, it's not crisp. Not crisp. So I assume that we're going to see the same problem even if we just use this guy directly. Give him a sec. He's thinking hard. Okay. Right. This thing is like really smudgy. But ignoring the fact that like we need to tune like some of our like averages and stuff for like blurring and stuff, it depends on size of the image. We still have the same problem here. So I think I stand by what? Like, how do I know this? Can I like select in here? So I'm just like looking at the histogram and trying to like understand what like my brain is doing here. I mean, it's very clear that like this is dark, this is light. When you look at like this picture on the left or on the right side, it is like jumping around. So there is something there that is like clearly different. I guess it makes sense too, by the way, that this edge is showing, because this is like a fairly significant change in brightness. I wonder if it's like, okay, so if we were to like look at this whole histogram, it's like, I think we have to somehow know, wait, okay, so this is, okay, so I guess like everything, it's like this hump is dark, I think. This one here. Why can't I fucking, hello? Like select a small portion. Yes, like this is dark. This is light. On the line is light. Yeah. Yeah, so there has to be some sort of comparison with adjacent blocks. It has to be. It has to be, right? It has to be some sort of like local comparison here. And do we take like the most it's clear to me that there is like a edge range, right? Like it's clear to me that all of these pixels in like here, can I fucking draw on this please with like a red pen or something? Like all of this stuff is like not what we care about, right? We care about like this and this. So like trying to leverage that information is probably important, which means that like when we're generating our run length encoding, I think the average is just wrong. I think using the average is wrong. I think we want to use like I think we want to know the direction of the edge. So like we know that here this is like a light to dark transition and this is a dark to light transition. And so using that information, we could pick like the peak value, like either the darkest or the lightest, because that's kind of what we're trying to optimize for here, right? And then what happens here? This is a dark to light transition and this is a dark to light transition, so that still works. Yeah, I like that. I like that. Okay, so let's so when we mark the edge, we want to mark the edge with edge dir. Light to dark and dark to light. And then here, instead of taking the total, hold on. We're getting somewhere. I guess we have unknown as well. But luckily, the unknown segment doesn't matter. Probably? So it's like on the first segment. So say this was cropped like this. Just like theoretically. If it was cropped like this, when you're parsing this stuff, you haven't seen an edge yet, right? So you need to know, you don't know if you're looking for the maximum or the minimum until you see the first edge, which is interesting. But after you have the first edge, you know like whether or not you're trying to I'm not sure that you so here I guess you don't know until you see the next edge whether or not the thing in the previous thing was a darker or lighter thing. Maybe we just always store both. Because it probably depends on like how the barcode scanner ends up processing this thing. Is that true? Do we just always want like the range of values in this area and then we pick based off of oscillation? That seems reasonable. Why was I not thinking that originally though? Because I always know yeah, I think it's like based off of the last two edges. I bet you there's something there, right? Oh my god, put this back. Right? It's like because this is light to dark and this is dark to light, I know that I want dark. But if it was like if you had like something in here, right, where you have dark to light and then dark to light again, you might want to take the average. Right? Like here you know that it's like a double increment. And so in here, you don't in here, what do you want? The lightest value, I guess? Because it's dark to light twice. And then in here, you want the lightest value because it's light to dark. Then if you had in here, it'd be like... Yeah, I'm not sure. I feel like you don't need double info here. I can't really like rationalize why, but I feel like you don't. Okay, so let's say that we store the min value and the max value as we're moving. And based off of the edge direction on mark, we pick which of those things that we store. I think that makes sense. Maybe we'll see that fall over. But we'll see. So self min is equal to min of val and self min. Max is the max. Okay. We don't care about... Oh, we do care about the length. Minimum should be max int usize. Okay. Cool. That makes sense so far. And then here we say to push is switch on edger. So if it's light to dark, it's max. And if it's dark to light, it's min. And then min is max int usize. Yeah. Max is 0. No entries 0. Yeah. Okay, this seems reasonable so far. Then here, when we mark the edge, we just have to mark the direction here. So, we just don't take the absolute value yet. Okay, and then... gradient dir is if this gradient is... It's like negative on the left, positive on the right. Wait, is this even... So on a dark to light, we're going to have zeros on the left, ones on the right, so this is going to be a big number. And if it's light to dark, then we're going to have negative numbers on the left, zeros on the right. So light to dark is like light to dark, else dark to light, I think. And then here we do this, I think. Yeah, these should be U8s. These should all be U8s. And then... I'm just going to do this, because I know that the outside should be white. This is like... abusing info that outside should always be light. Okay. Okay, that's good news. That looks a lot better. Can we do it with like the smaller image again? Can we just do this with small? Okay, that feels a lot better, right? Contrast here is really good. And I would say it looks to me like this is like very bisectable now. That's a lot better. A lot better. Sick. Obviously not perfect, but workable. Okay, so let's try to find the the start and end markers now. Find barcode. Based on RLE. So we are looking for something where we have a sequence in our thing of dark, light, dark, where they are all approximately the same width, right? So well, I guess we can do this on each row. We can kind of do this here, where we are printing this thing. So let's make our we need like I think we have like our old barcode scanner. And unfortunately, this thing is like not really correct anymore because it was working on like image directly. So we have Barcode Scanner 2. And he is working on a row, maybe. Something like this, right? Something like this. And we're gonna say find barcode. Okay, so we probably want like our output image here as well. I think that's still true. And this will return like the pixel positions, I guess. Or maybe the row, the like RLE index. Yeah. Yeah. I think that makes sense. So we are looking for sequences. I guess it's more like 0 to row len -3 or something. We have like A is row at this, B is this, and C is this. This is kind of like find, start, end sequence. We're looking for, again, dark, light, dark of consistent size. I think also let's store like the pixel position here, which will make it easier to write into this debug image later. So for each of these, I guess x pixels plus equals a length. Yeah. Okay. Cool. Cool. This makes sense so far. So what are we looking for? It's like if A minus B is like, I guess like diff A length and B length is less than, 2 and B length, I guess A length and C length is less than 2. This is like a thing. We should have like, length variation allowed or something. Yeah. So this is like this. These are in pixels, which is annoying. Because like if we change the image size that we want later, these thresholds are gonna have to change, but maybe it's fine. Okay, so if we see this, so this thing might return nothing. And here we're gonna say debug info at width plus x pixels. And I guess this is actually more like one row of the image, because we're doing this on one row at a time independently, which is maybe wrong, but like whatever. So this is like potential barcode start. Okay, that's promising. And then this returns RLE index. Okay, so let's start here. Let's start here. So for each row, we're going to make a barcode scanner. Debug is debug, which doesn't exist right now. Did we lose it? I guess this guy lives here somewhere. Who gives a fuck? And I would like to write out this thing with like not sure yet. Okay. Write debug is taking on a thing of U8. To right here is if the debug info is none, then we return the original image. Otherwise, we return this thing. Okay. Cool, that works, I think. Row is row RLE row items. Okay. And then we just do this. So this should mark the debug info. This needs to go from like for this row, right? So we need to go from like row start is, I don't know, man. Y times debug width. Row end is y plus 1 times debug width. Okay, so something like this. Close. 211. This is easier like that. Expect use size found bool. True. True, 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 true. I fucked up my brackets here. Bracket here and not here. Okay, expected U8 found bool, 437. Yep. Okay, so when we called write debug, where did it go? Out ppm. Okay, so good news. We found start sequence here. Now, how? Because we didn't actually check dark, light, dark. We just checked that there were 3 segments of approximately the same length, which is a little stupid. Also, our threshold must not be small enough. And then also the yellow mark here is in the wrong spot. Barcode scanner 2. So this needs to get bigger. And then here we want to do X pixel increases after. Okay, let's look at this. Write debug is fucked up because he needs a buffered writer. Okay, let's try that. much faster. And actually still not so great. So this is working fine. Oh, it's because we're only searching once. Wait, so maybe the threshold was fine. This might have been okay. And it might be that we want to go like, yeah, maybe that's fine. Also we want to say, if, I guess like if B, we need to do like a bunch of early returns probably. If B value, what are our options in here? It's like length and val, right? So if B val is less than A val, return or continue, probably. Right? Is that true? If B val is less than A val, it means that it was light, dark, light. If C val is greater than B val, then we have like a problem. And in reality, we probably want to see like sufficient difference here. I guess we should say like is brighter almost, right? Bright. Yeah, not sure. Because we need to handle that eventually we're going to be seeing this shit. And we need to like account for the fact that this, like a double dark to light, this is like unknown brightness. We don't know if this is light or dark. But maybe we can ignore that problem for now. You know? I guess it's like find dark to light. Maybe when we make this thing, we like compress these two together. Yeah, that might be right. I think that we probably want to say that if we go dark to light twice, I guess we don't know which side needs to be squished together. Yeah. All your filters are pixels and you don't really care about pixels. I don't think that's true. I don't think that's true. I think I do care about pixels. Because like at this point, like this is a visualization of our run length encoded thing. I think that like, I am assuming at this point that we will be able to create a consistently sized barcode image, right? So we just have to find an image. If we can like extract a barcode from a larger image and always have that barcode be 768 pixels wide, then I do care about pixels. That's kind of the assumption I'm working under right now. Otherwise, I have to think about like ratios of like some base unit or something that I don't really want to think about. I think it just like simplifies the problem. Yeah, I have to figure out eventually how I'm going to bucket this as light or dark. The double transition. But maybe also we can just say that that fucking doesn't matter. That's what I'm going to do for now. Ignore that problem. Just ignore it. Don't think about it. Which means that we can just do this. That's fine. So if B is less than A, so if this is darker than this, no good. If this is brighter than this, also no good. Then if diff A length B length is greater than length variation allowed, continue. Then we do the same thing for B and C. Then at this point, we're good. Yeah. Yeah, this all makes sense, I think. Okay. Cool. So we're finding the first potential start end index thing here. And now we want to extract the module width from this thing, right? So I guess we just use A length here. right? And we should just be able to jump ahead until we're like at approximately the right spot, right? So we know actually that there's like, we know approximately how many, well, we know exactly how many transitions there should be, right? Because each character in the barcode or whatever, each like number in the barcode is represented by 7 modules, if I remember correctly. I think it was 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So it's we should be seeing 7 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 12. 7 times 12. So we can jump forward like this needs to be like from start index. Okay. And then we jump forward just like a fuck ton of these. So we say if find start end sequence, RLE index plus 7 times 12, but plus the middle as well. So this is 1, 2, 3, 4, 5, 6, 7, maybe. What's this middle sequence? 1, 2, 3, 4, 5. So plus 5. Yeah, so it's 7 transitions per character, 12 chars, plus 5 in the middle sequence. Yep. So if we find a start end sequence here, end RLE index. If end RLE index, maybe this is fine. I guess we need to like check the like distance between these guys, right? So module size a length, and we're expecting we're expecting like a certain distance between these guys, right? It's like oh, I'm a dumbass. Hold on. Module transitions here. It's 7 things, but 4 transitions. 4 transitions per character. My bad. So then it's 7 modules per character, 12 cars, and then 5 modules middle, 3 start, 3 end, right? So the expected width here is 7 times 12 plus 5 plus 3 plus 3. Okay. And we're saying like we need to like count RLE size pixels or something from, you know, row from A RL index here to end RLE index. Okay. Return like, but end RLE index is start of the end segment, so drop last 3. Yes. And then we just say like module expected width modules times module size. Like, we need to say that this is like check if within some tolerance, right? So if this, I guess it's like error is width pixels minus, we have like expected width pix is expected width modules times module size. Error is absolute value of expected width px minus width px, right? This is actually diff because you're unsigned probably, and we just say like error times 100. How can we, so error in pixels, this is error pixels, out of expected width pixels, this is the percentage error, error percent. Yep, and this can be done on integer math. And then we just say if error percent is greater than 5. Yeah. And then here we also want to set the debug info to render this thing as blue. Okay. Count RLE size pixels. Builds a list of run length and normalize that rather than sampling a pixel grid. I'm not sampling a pixel grid. I am working on RLE. Maybe I don't understand what you're saying, but I am working on the run length encoded values directly. I'm only using the pixels for like error calculation because like they're variable size, kind of like by definition. Row segment, I guess, is a list of RLE items. And just like for row segment, total is elem.length increase, return the total. And var total is 0, use size, probably. Okay. That seems like it might do something. I don't want optimized. Integer overflow. Oh, because the row length might be less than 3. If row len is less than 3, return null. Nothing to see here. Really? Hello? Hello? How can this overflow? Oh. Yeah, it's if this, if row len minus 3 is less than start index. That's what it is. There we go. Okay, let's take a look. Okay, bad news. Am I stupid? Why did we get more yellow pixels here after what we just did? That seems wrong. And also, why are these matching? Like, hello? You're calling it recursively? Oh, true. Yeah. So you're saying, like, why is it recursive? Well, because the start end sequence, like, they're the same. So, like, the fact that, like, we're kind of, like, going forwards here, I think this is, like, close to correct. What I don't understand is this stuff here. I don't think this should be happening. Because before we were just doing, like, return RLE index like this, right? I think that's what we were doing before. Yeah, there's something wrong here. It's because this is wrong. X pixels has to be count row from 0 to start index. We've got the X offset needs to start at the start. I think. Okay, yeah, that should do it. What, don't you want to call it sequentially instead? Don't you want to find a start and another start? Well, I'm looking for a start end that is specifically like a specific distance away. Right? So you're right kind of that like probably recursive is kind of wrong here to some extent. But I think it's like correct enough, right? Because what's gonna happen now is I'm gonna find the first one, scan forwards, find the second one, scan forwards again. I'm gonna like hit the same ones over and over again. But that's okay. What's going on here? Because start index might be out of bounds. Which I think just gets fixed if I move this calculation down. Okay, so that's good. Now, we are seeing yellow lines at dark light dark, dark light dark, dark light dark, so that's pretty good. Now what I'm concerned about is the fact that this is not getting hit. So can we print the error tolerances? Okay. There's a lot of other prints that is like making this impossible to process. Okay, so that's never working. Hi, Mom. Like, this, my mom will never be said hello to. Yeah, interesting. Why not do multiple contrast passes? That's not crazy. It's not crazy. Okay, so why is this not working? This must be wrong. 4 transitions per character. Plus 12 characters. Let's just try like limiting that. Maybe I was doing too much. No? Can we... I feel like this is right. Yeah, what am I missing here? What am I missing here? So... Can we... If row len is less than 3, return. If row len minus 3 is less than start index, return null. That seems reasonable. Like, what am I missing? That was fucking stupid. Like, end, potential end RLE index. Can we do this? Right. If potential end index is less than self-RLN. Does this ever happen? Yes. So it's not like we're never... Oh, and we know that's happening because we're seeing yellow. Oh, I'm a dumbass. Dude. Because we're searching... No. It's because we're searching for start. This is like a thing that matches start and end, but we're also trying to match the end as the start. This is find start sequence, which should call find start end sequence, which shouldn't do this like recursive shit like you guys were fucking saying. I just didn't catch on. So just don't recurse here. Yeah. Find start end sequence. Okay. So it's like something like this now. And this thing probably needs to return more stuff from here. Module width and RLE index. Here we go. We're getting somewhere. My dumbass just couldn't get there. So we return the RLE index and the module width is a length. Boom. Cool. So then we say here, const start is this. Delete all of this. Then we try to find the end. Yes. So this is start.RLE index here. Yup. Okay, this feels like it might work. True. This is unused, I guess. It's used down here. Okay, here we go. This is not called this anymore. This is called end now. Okay. Huge. And I guess it's like... and... we probably want to make sure that, like, check that end module width is approximately equal to start module width. Or, like, better is to constrain it. But that's fine. This might, like, work now. So let's just, like, run this and see what happens. Nothing, huh? Okay, so here... Interesting. So we're iterating over each element here, which is maybe wrong. Let's think. So here we're like, find the start sequence. Find the start end sequence. If we don't find it, continue. Then we like look for the end, which we're not finding. So this never happens. And then we like keep going. So shouldn't we be seeing like more yellow over here? I would think, right? Because, and we are, yeah, we're only ever seeing the first one, which is bad. That means that like this find start end sequence must be doing something fucking wrong. I just don't know what though. So we're iterating from maybe, yeah, this, yeah, so here we find one. I assume this is happening. Oh, fuck. Right, looking for end. This must happen. It must. No? That's interesting. Am I fucking off my fucking rocker? How are we getting any yellow pixels if this is never happening? Oh, good fucking call. Good fucking call. I do have to update this. Good fucking call. Oopies. Good eye. Good eye. Okay, there we go. So now we are seeing looking for end. We never find it, but that's okay. So what happens if we just, say +1 here? Do we start finding it then? Yes, we do, right? And now the question is okay, so why then are we not finding the end? Oh, wait. We are. We're just drawing the blue line in the wrong spot. Hold on. That's a really good sign. Wait. Wait, this is so huge for us. This is so big. Okay, so how far are we supposed to go? 4 modules, 12 characters, plus 5 in the middle. Plus 3 at the start. Okay, no dice. What if we chop off that 3? Okay, so some of these are hitting. Now, I would love to see who they're matching, because obviously we're doing something fucking stupid. So can we change our debug purpose to have potential barcode end? And if we see this, then we have debug x pixels plus width pixels is his barcode end. And when we use this guy, we need to write barcode end as a different color. We aren't calling them blue and then overriding them with yellow, are we? We might be. That seems like the type of thing we might do. Okay. Yeah, so he's definitely matching, like... The fuck? This must not be right. It can't be. Yeah, that can't be right. It can't be right. Right? Like, what the fuck? Like, this is nothing. This is nothing. Can we do... I think we need to keep searching when we fuck it up. So, like, for... Yeah, there needs to be a loop here, which is wrong. Whatever. We'll just do this for now. Okay. If potential end is greater than or equal, greater than self row, len, continue. Okay. Okay, error is 1 here in a lot of these, which is interesting. So it's interesting that, like, I must be missing something where... Is the error percentage just not big enough? Yeah, I mean, the fact that this is crashing seems like a bug. Right? This should never happen if I understand this correctly. This should be start to end. That's why. Oh, let's fucking go, dude. I was just using the wrong index. So I was using the loop index here instead of the start sequence index. And then this really doesn't need this. This should just be fucking 0. Unconditionally. Okay. A little bit of a pain in the ass, but we definitely have like a solid red line on the end. We found it. Now this is wrong. It looks like we're starting to search too early now because we didn't do the +3 here. Oh yeah. And then let's do a like -1 for error tolerance. Yeah, that's pretty good. That's pretty good. Cool. Cool. So now can we start parsing the fucking left-hand digits? I think we should. I think so. So can we do parse left? Did you lower the error tolerance? Nope. No, I did not, but it is worth checking. 5 too low. Why? Expected width is expected width modules. Maybe this is wrong. Maybe I've got a problem here. Or maybe this is like... Yeah, can we... Okay. Looking for end. What is our like typical error? Like a lot of 12s and a lot of 30s. Interesting. Yeah, so can we say we must be doing something wrong here. Like, this must not be right. I'm just gonna throw a -1 on here because I had to on the other side as well. But I don't really understand it. So the start, what are we returning here? When we say find start end sequence, we are returning RLE index, so this. So if we find the start sequence where the first pixel is 0, then we're returning the first run length encoded thing. Okay. Then, oh, is it that when we count this thing, we are not including the last element? Does that cause a problem? So this with pixels is from, we're measuring like here to like here. We're including this white section here. So how many is that? That's 7 modules times 12 plus the 3 at the start plus the 5 in the middle. 1, 2. Wait, is 5 in the middle, right? 1, 2, 3, 4, 5, 6, 7. Am I crazy for thinking this is 7? 1, 2, 3, 4, 5. It's 5. Middle is 5 modules wide. Yeah, okay. Space bar space. Oh, I see. It's probably like space bar space bar space. It's probably this first patch here is part of the next number, and that confused me. Okay. 7 times 12. Yeah, I'm a little confused here. Like, it does feel like this is right. What is, can we log, RLEs, like, RLE width? So, like, end RLE index minus start RLE index. Does that give us any interesting information? So when the error is low, it's 56. Which is that right? 7 times 12. Dude, that's so low. Oh, it's not 7, it's 4. My bad. 48 plus 5, 53 plus 3, 56. Yeah, I mean, that's right. That's definitely right. So 56 is the right answer for how far away this thing should be. So can we... 4 times 12 plus 5 plus 3. Yes, this -1 I feel like shouldn't happen. But like, how come when we take the -1 out, we can't see 56, which is interesting. Oh no, we do see one here. But when we take away that -1, yeah, what the fuck? Oh, I guess we do see some of 55 on here as well. So if there's 55 switches, doesn't that mean like we're missing a transition somewhere? Like, isn't that what that means? And I guess we are sometimes, right? Like, this shit's happening. So maybe that's part of the problem, is that like, we're not doing any like smoothing of the edges vertically. Yeah, so that's probably what it is that there's a lot of these guys that are doing this. Okay. Okay, so that explains something, which means that we're probably going to need to do some like improved image processing here. That's the answer. Is that like, hold on, why is that happening? Hold on. We are writing edges here. Okay. Can we write them on top of RLE back and forth? What is happening here? Something about this doesn't feel right. I guess there are just holes. Maybe our edge tolerance is too low? Where is that coming from? Gradient thresh. Hold on. How do I get these fucking holes filled in? Wait, okay, so if this average is less than the last average and we're increasing and the last average is greater than the gradient threshold, then we mark the edge. So if we are, and we're not even averaging anymore, which is funny. I need to draw this on top of the original image, actually, again. Like, why are we still missing some? I feel like we shouldn't be missing shit, right? Why is this happening? Would you have decided it was impossible to detect and decide to fill the holes? That's definitely like an option. That is an option. I just want to understand why this isn't happening first. Is it because we're blurring? Could be. It could be. If we take off that blur, just for a second here. That's interesting. That's interesting. I guess, like... No, something about that seems fucked. Something about that seems fucked. There might be a bug here. Oh no, wait. Were we just not refreshing enough? I feel like there are no holes now. I didn't really change that much. I think I just wasn't necessarily refreshing the image and that was giving me incorrect conclusions. Hold on. Bring this back up. Refresh image. Yeah, wait, maybe this is just fine. Yeah, maybe this is better. Can we draw this? Can we look at the RLE back and forth? No, there are definitely still holes. Okay, so we are gonna have to like heal this in some way. Like, just, like, dilate the edges or something. Yeah, we have to do something like check if there's an edge, like, extend the edges vertically. Or something. Let's just try that. I think that's reasonable. So we're gonna go over here and I guess we could do this. This is, I think, kind of the same thing. If we extend this, like, horizontal gradient detection, I think that does something. I don't know what, but something. Okay. There's still this, though. So maybe that wasn't the play. Okay, let's go back. Yeah, so maybe we just say... I'm trying to do this without, like, stashing all of the, like, stashing the edges first. I was gonna try to do this, like, all in one pass. But maybe that's just, like, not reasonable. Maybe that's not reasonable. So maybe... we split this. Okay, get status, get add issue, get commit. So we need to we need like an edge pass is basically what we're saying here, I think. So this loop where we iterate over all the edges gets duplicated, and the first time it's all about just stashing edge data. So fuck anything row RLE related. This stuff is still good. This is all still there. Then fuck all of this. Okay. Now we generate row RLE based off that edge data. So we probably need to stash the gradient direction. We were using that. But we could probably figure that out kind of without that information. Yeah. So hold on. We're getting somewhere. What's RLE? Run length encoded. So we're trying to kind of say, like, between these edges, we have, like, a section of black that's, like, 10 pixels wide or something. Okay. Wait, we're getting somewhere. So how do we determine if this is an edge? We look at edges at y times edges width plus x. Okay. If this is greater than 0, this is an edge. But I guess we just do this. We need to find the edge direction, which I haven't really decided how to do yet. Left, I guess, is image inner data. I want to store the edge direction here. Can we in edges? Let's just do this. This is not how I want to do this, but for now it's the easiest way. Fix me, fold into edge data, but that's fine. It's fine. So this is like gradients at y times edges width plus x minus 1. Yes. Is equal to this gradient. Yeah, okay. So now we have the direction here. Is gradients at y times edges dot width plus x. Assert that the gradient is not equal to 0. It shouldn't be, but just in case. And then we can say if gradient is greater than 0, greater than 0 is negative on the left, positive on the right, which means that the negative was bright, dark was on the left. So this is if gradient is less than 0, it's light to dark, else dark to light. Okay, here we go. Okay. Now, we're chilling there, right? Chilling there. I guess it's more like... I think it's fine, yeah. What's he pissed about? He doesn't know what this is. There we go. Okay. So this should just be back in the same state we were in before, but it's not. Because this is not happening? Why? The fuck? Okay, if I take this out, how fucked is it? I assume very fucked, but... okay, there must be just like an edge case on 0 or something. No, this looks different than it did before. Am I stashing this in the wrong space? So everywhere where we have... Everywhere where we have edge data, we should have gradient data along with it. So does that mean that sometimes that the like this gradient is sometimes just 0? Yeah, I guess so. I guess sometimes the gradient is just 0. Interesting. That seems like a bug. I don't know how, but that seems like a fucking bug. It's probably that, like... Okay, wait, hold on. So this is happening if we start moving down, and that can happen because even if the gradient here is 0, because the gradient was positive before, and now after the averaging, it's less than 0. So we actually need to use last gradient. And we probably want like the averaged gradient or something. Is it okay if we do like signed averaging? Probably. I'm not 100% on this, but there's like a chance that's fine. Because the gradient should always be moving in the same direction. Yeah. I think this is okay. Oh, this is also just not averaging right now, so who fucking gives a shit? Okay, hold on, let's do this. Okay, does that change anything? So now this is mad because Let's do a truncating division here. Not that it fucking matters. God damn it, dude. Fuck everything. Fuck everything. Fuck everything. This should be as T, actually. Okay, there we go. Fuck! Does this look okay still? We're just losing edges, yeah. Because we're, we need to do some of this. Last abs average. Increasing is if... Okay, let's try this. Last averaged is... signed averaged is this. And, abs averaged is the absolute value of saveraged. Okay, now we can make sure that we do this right everywhere. It's abs averaged here. Abs averaged here. Saveraged here. Oopsies, and this should be last average. Alright, please God. Okay, edges are back. Huge. Run length encoded. We're so fucking back, baby. We're so back. And now we can start actually trying to do that like up down shit, right? So here we're looking for like if any of our surrounding pixels are an edge, specifically like above or below. Probably, right? So like we're probably trying to do something like edges, apply kernel at location, where we're trying to do like sibling edge detect is going to be like something where we look above and below. Vertical sibling detect? Yeah. Something like this? Where we're looking like above and below, but not here, right? And then we have horizontal sibling detect. Is just the other way. Okay. So horizontal sibling detect at x, y. Okay. Has horizontal siblings. If has horizontal siblings, we have nothing to do here. And then if has vertical siblings, I guess like apply kernel vertical sibling detect. And we're taking the sum of this thing and maybe like dividing by 2? Maybe? I don't know. Right? It's like one above, one below or something. So like this just gives us the... Oh, but we don't know. We actually need to check them. We have to check them manually. We have to check them manually because we need to know, we need to look at the equivalent gradient as well. That's annoying. So for like y minus 1 to y plus 1, you know, sibling, like sibling y or something. I don't know, man. Then we have like x, sibling x. I guess we really want, like, here we want to skip our row, so it's actually more like this, where we have like a list of just like one above and one below. Cool. If y is greater than the height, we continue. And if sibling, here we actually want to do, we don't want to double fucking check. So here we actually be careful. If x is equal to 0, it's x plus 1. You know, x siblings is this. Else if x is equal to, it's just else. Yeah, else if x is equal to edges width minus 1, it's only the left sibling. Else it's both. This is stupid, but whatever. I'm sure there's a better way to do this. And then we go for x siblings. Okay, there we go. No fucking bullshit to deal with now. And oh my god. Fine, I'll put a space, you asshole. Okay. So if this, now we're chill, I think. This is wrong, again. Because if we're above, then we do want to check Rx. I'm a dumbass. So we actually do still want to do it this way. God damn it. Okay. Okay, so here we continue. If sibling x is equal to x and sibling y is equal to y, we also continue. We skip our center. What am I even doing right now? What am I fucking trying to do? I'm fucking trying. God damn it. If sibling y is equal to y, continue, then I check all x's. Yes. God damn it, dude. Okay. If edges exists. God damn it, dude. God damn it. God damn it. Okay, here we go. Then we copy it over. God damn it. Why did that take me so long? And here, again, we're not actually doing this. We're just putting this in our row RLE. So it's actually kind of more like this. So this is our gradient. We convert our gradient into an edge direction, and then we mark the edge. And then we break. Jesus. Fuck it. Fuck it. No. Why now? How come it's fucking true here? If edges data other index is greater than 0. Oh. Yeah, I feel like this shouldn't change. Oh yeah, we're chilling. Okay. Okay, that helped. I saw the stripies decrease. But it looks like there are still holes. Right, specifically here at the end. Can we look at that in the other one? Wait, it's actually fine, no? Oh yeah, it's just because we're over-detecting. Wait, that's fine. So it's more stuff like this that we should be worried about. Here. Yeah, so there's still a hole here. So we just extend the search up and down, right? We just search like 2 above and 2 below. Say fuck it. Yeah. I mean, even then, it's not good enough. Not good enough. But maybe mostly good enough? No, there's still a lot in here. What's our, like, output look like? Yeah, a lot missed still. So, like, all of this stuff is still a problem. Interesting. Oh, we probably want to take the biggest one as well, right? There might be somewhere the gradient is really low and we're like thresholding that out or something. God damn it, dude. I mean, what I really want is like... I feel like I really want to like blur the edges or something. I feel like that's what I want. Can I just run like... After we calculate the edges, what if I just do like... Apply kernel... Like, what if I just blurred the fuck out of the edges themselves? You know? So we did like edges, apply kernel at location is... I guess we need like edges too, which is a little funny. Edges 2 at this is something like this. Oh, but the fucking blur will like remove like the crispiness of the edge. Which is a little annoying. Right? Like if we, yeah, there's... It will remove the crispiness. Fuck! So what do I actually want? I feel like what I was doing here, where I was trying to just like check if I have anyone anywhere, seemed kind of right. Can we just like fuck up the edge thing as well? Yeah, if I do this in its own pass... I think edges, can we just do edges 2 here? We just assign here. Can we do like edges 2 is mem copy edges 2 data from edges data. Then here, assign to edges 2 here. At y times edges width plus x or whatever is equal to edges data at other index. I just want to visualize what we're fucking doing here. So can I fucking print out edges 2 here? I just want to see what we're doing. Right, so this is edges. So are there still holes? Right, like this should not still be here. Unless there was like a double hole before. Could be. Okay. So, let's go look. I guess let's look at the fucking RLE ppm. So where is it like fucked? Specifically here between like the gray and black. So that's kind of like the second big black bar. This guy. He's got like like a lot of holes here. Okay, cool. So on edges, if we look at second big black bar, like I feel like we're not patching the holes. Am I crazy? Yeah, like why do these look the same? That's the bug. That's the bug. I feel like we were supposed to check above and below and be like, there's a fucking edge there. Fucking copy paste the edge. And that's not happening, which explains why we're not fucking fixing anything. Okay. Copying edge, baby. Or can we just write like a breakpoint? Just to fucking crash the program here? Is this happening? Yeah, that is happening. Interesting. So why is it not happening here? Like very clearly, these should be different pictures. Has horizontal siblings? Oh. This is wrong, that's why. Horizontal should only be like strictly horizontal. He's looking for things that are diagonal as well, which is causing all sorts of fucking problems. Much better, dude. Let's go. Let's go. I'm an idiot. Oh, that's a lot cleaner. Yeah, that's beautiful. Beautiful. Look at that. That is much cleaner signal. Jesus Christ. Okay. What a pain in my ass. But we got there. Okay. So, now, how is our detection here? Not fantastic. Okay, so what the fuck is going on there? Why is this bad? Like, what the fuck is it? Like, obviously this is wrong too, right? So I think what's happening is our noise, we fucked up our noise thresholds at some point. Can we bring this back up? Edges 2. Yeah, that's a lot better. A lot less, like, random noise, I think. Now, does that mean that this was working better? Not this one. The output? Okay, yeah, nice. Oh! Nice, solid blue line. Almost. That's almost perfect. And then is the red, where it's diagnosing that it matches, pretty good? Here, we're kind of matching too early sometimes. But for the most part, it's okay. Fucking finally. And now our error... can we log only the errors that matched? Barcode scanner 2. Uh, okay, sure. I think that's fine. I think that's fine. Okay, so what do we actually want to do here? This is a little concerning. A little concerning here. I don't know what we're going to do about that. Okay. I think this is doable. Okay. So, let's try to find some patterns. So, once we have found the start sequence, we want to like consume dark somehow. I don't really know what this returns. I don't know yet. So like, I guess it's like, while this like row at RLE index start val is this, right? And as we like iterate this row, while this thing is like darker than, I guess it's like getting darker. Yeah. So while this is getting darker, we say last val plus equals 1. No, last val is equal to, here. Okay. Yep, that makes sense. Then we say RLE index is incremented by 1. So that seems reasonable. Then we have consume light, which is going to look very similar. We're going to do the same thing, but this with this flipped. Yes. Okay. So can we do something like, I want to print over top of this thing debug info for dark and light segments now. Right? So specifically I'm hoping that this stuff will get marked as dark. That's what we're really hoping to see here. So I guess for each of these, oh, it's so hard to measure. Debug. So I guess we have like start pix is something. Count this from 0 to RLE index. Yeah, something like this. Jesus. Okay. End index. So then we're gonna like say end x is start index to this or something, and then we color in everything. So for self debug from start x to end x, can we mark that as like dark? This is kind of what I'm looking for. Something like this. And then I guess we fucking copy paste this to consume light and put a fix me on it. Consume light, fix me, heavily duplicated. But for now, this should be good enough for us to be able to just like alternate consume light and consume dark and just kind of see how that looks. Can we just do like this? Like this? Okay. So what I want to do is I want to say, let's look at, we found like a start sequence. While true, I don't really know. We expect this to be dark immediately, then light. Right? So this is probably like while like, you know, scan iterator is this. Then we're looking for like while this is less than the row length, I guess. Something like this. Looks good so far. Okay. Operator is wrong. Uh-huh. Just like a little dot vowels everywhere. Okay. Like this. And then this guy needs the same treatment, huh? Okay. Oopsies, I missed one. Jesus Christ. What a disaster. What a disaster. Start index is larger than end index? True, huh? Hit a little, slap a little 0 on there. Okay. 259. This needs to be like RLE index is less than self row len and this. We need to give that treatment to both of these. What a disaster. I know. 258. Oh my god. If RLE index is greater than or equal to self row len return. Oh, what? This is what I call shit code. I invented it. It's garbage. Okay, but now we can at least fucking see something. So, out. Okay, this is a really good sign, right? So what we're seeing here is if we just alternate dark and light checks using this scanner, we are correctly identifying these things, right? Specifically like in sections like down here where it's like a little ambiguous, right? We have correctly like removed those sections, which is good. These strips that you're seeing here are because there are some rows that are not correctly identified as like parts of a barcode, which is fine. We can just like leave those for now. But the ones that we are checking are getting like max contrast applied correctly, which is good. Because that means that the procedure of like the procedure of actually checking these dark light values should be pretty straightforward. Okay, I would love to keep going and actually scan the barcode now, but it is 2 hours and 15 minutes in. We're past our target of 4 o'clock, so I think that we can kind of title this YouTube video, we can call today's stream like success, like something about successfully pre-processing our barcode finally. with run length encoding or something. And we'll come back, I guess, tomorrow and actually try to like read the values. Yeah. Reconstruct it. Look at this shit. Wow, guys, look, we made art. Look at that. It's pretty. It looks like when people are like sketching things out. That's funny. Okay. Anyways, we'll call it here for today. I think that we're very close to something that's like actually parsable, which is sick. So yeah, thanks for watching, guys. If you think we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is 4:15 now, so anywhere between 3 hours and 45 minutes ago and 15 minutes ago is, when you should expect to see us live. A lot of this stuff ends up on YouTube. Like, for example, today, this segment on run length encoding will end up on the YouTube channel, link in the Twitch description. Some stuff does not, right? So, in like the happy hour segment or whatever the fuck we call it today, we were doing like some prep work for this, like taking the edge detector stuff that we put on YouTube yesterday and replacing it with like barcode specific horizontally motivated edge detection, right? So the reason that we kind of don't place everything is because, one, the YouTube algorithm is extremely fickle, and so we need to have like some sort of like consistently titleable, clickable thing. But also, we put the rest of the stuff on Patreon or under YouTube members or in Twitch VODs, where if you support on whatever platform makes sense for you, you get the remaining VODs. The stream will stop happening when I run out of money, so this gives us something to give people who want to continue, help contribute to keeping the stream alive. So please consider using your Twitch Primes, but obviously, if not, no big dealio. Okay, I think that's it. All the plugin, YouTube, peace out. Twitch, let's find someone to raid.